All right, so today we are looking at distance problems in the form distance of A is equal to distance of B. And in these kind of word problems involving distance or distance problems, we're going to find the rates and times for vehicles are going to be different, but the distance covered will be the exact same. So because the distance covered is going to be the exact same, we can say that distance of A is equal to distance of B. All right, and just quick recall that distance is equal to rate multiplied by time. So distance is equal to rate multiplied by time. So R times T. R is our rate or our speed. And usually these examples are in kilometers per hour. Therefore, then our time will be in hours and our distance will be in kilometers. So here is our first example. A car leaves Ottawa traveling at 40 kilometers per hour. A second car leaves Ottawa 1 hour later and travels at 60 kilometers per hour. How far from Ottawa does the second car overtake the first? So again, it's a good idea to just kind of draw a little sketch just to have an idea of what's going on. So car or vehicle A and its rate and time we'll put down here. So car A, its rate was 40 kilometers per hour. So its rate is 40. And our second vehicle, B, its rate is 60 kilometers per hour. So we have a rate of 60. And what are we trying to solve for is how far from Ottawa does the second car overtake the first. So we're looking at distance. We're trying to solve for distance. But to be able to solve for distance, we need our rate as well as the time. All right, so let's call the time for car B, we can call that X, because the second car B, is the one that's going to overtake the first one. So we can solve for X and then multiply the two together to give us our distance. All right, so therefore our time for our first car will be X plus 1. All right, so the second car left Ottawa 1 hour later, so therefore we can call car A X plus 1. Now we can set up our formula. So distance of A is equal to distance of B, and we know that D is equal to RT, so RT of A is going to equal to RT of B. So rate of A is 40, we multiplied it by X plus 1. Our rate of our second car is 60, and we're going to multiply it by X. Next, we'll multiply this out. So 40X, and then 40 times 1, that's plus 40, and that's equal to 60X. And we'll collect our like terms. So I'm going to bring the 60X to this side. I'm going to subtract the 60X, and I get 40 minus 60, that's negative 20X. Plus 40 is equal to 0. We've got nothing on that side. Then I'm just going to subtract the 40 to both sides. That gives me negative 20X equals negative 40. And I'm just going to take this up here. And what I have to do next is divide by negative 20 on both sides. And that gives me negative 40 divided by negative 20, which is 2 hours. All right, we solved for X here, which is 2 hours. But if we go back to our question, The question is asking how far from Ottawa does the second car overtake the first, which means we're looking for distance. So we have to multiply rate times time and figure out our distance. So therefore, our distance will be RT. The rate of that car was 60 kilometers per hour. And now we know that the time is 2 hours. And multiply the two together, our distance is equal to 120 kilometers. All right, so that's our distance. So the last thing we have to do is write out the statement. Therefore, basically, it took the second car 2 hours to catch up to the first car. So he would have traveled 120 kilometers. All right, so how far from Ottawa does the second car overtake the first? So in 120 kilometers. So we can write the statement. I'm just going to write the statement right up here. I'm running out of room. So it takes the second car 2 hours, and it travels 120 kilometers. It's the second car 2 hours, and it travels 120 kilometers to catch up to the first car. All right, our next example is Turtle Terry. I've just used TT. Leaves Regina at 10 a.m. and averages 40 kilometers per hour. At 12:30 p.m., Hot Rod, I've abbreviated it to HR, leaves Regina and catches up to Turtle Terry at 2:30 p.m. What was Hot Rod's speed? Okay, so Turtle Terry and its rate. We know Turtle Terry has a rate of 40 kilometers per hour. And Hot Rod, we don't know the rate. That's what we're trying to solve for. So rate is X. We don't know what the rate is. A time, we're going to use, Turtle Terry leaves at 10 a.m. and Hot Rod catches up to Turtle Terry at 2:30 p.m. So from 10 o'clock to 2:30 p.m., that is 4.5 hours. And the time for Hot Rod was from 12:30 to 2:30, which is 2 hours. All right, and so in this question, distance D of A is equal to D of B. And just remember again that distance is equal to rate multiplied by time. So RT is equal to RT. Rate and time of A, which is Turtle Terry, is going to be, mixed up, so I'll just do it the same way as in the modules. So it's T, which is 2 hours times X, so 2 times X, or X times 2, it's the same thing. We're just used to seeing it this way. And then for Turtle Terry, it's 40 times 4.5. All right, so we'll just multiply this out. So 2x is equal to 40 times 4.5, which is 180. And then we'll divide by 2. And that gives us x is equal to 90. So if we go back up, we already called the rate for Hot Rod is x. So therefore, the Hot Rod is traveling at 90 kilometers per hour.